That last minute was only 8 and change. I could have squeaked out another problem or two, but here we go. Number 21. We're still solving by completing the square. This one's kind of nice because it doesn't have a leading coefficient. Not quite as nice because it's got an odd middle term. So we're going to take -3, divide it by 2, and then square it to come up with what goes here. -3 times -3 is 9. 2 times 2 would be 4. So this is going to be plus 9/4. And you're like, well, that's not too bad, but keep in mind, if I add 9/4 here, I got to subtract 9/4 out here. This guy here is going to be x minus 3/2 squared. And then I'm going to need to do some fraction math here. I want to subtract fractions, so they need to have a common denominator, which in this case would be 4. If I multiply that 1 times 4, I've got to multiply the 8 times 4 and get -32. -32 minus 9 is -41/4. And now we're at the point where we can solve this by the square root method. We need to get the square root by itself. So it's x minus 3/2 squared is equal to 41/4. We'll take the square root of both sides. I get x minus 3/2 is equal to plus or minus the square root of 41. I'm going to take the bottom out. What's the square root of 4? Hopefully you're screaming, it's 2, Miss Harris, it's 2. All right, then we're going to add 3/2 to both sides. So this is going to be 3/2 plus or minus the square root of 41/2. Keep in mind, it's multiple choice, so you might see it this way. You could also see it, just like on a PSAT, you could also see it this way on a PSAT, where they put it all over 1, 2. In fact, I would say this way is more common if they have a common denominator than you would see it that way. All right, number 6, or part 6, we are solving by using the quadratic formula. You should have this memorized. If you don't have it memorized, you should have it on your note card. Here's your quadratic formula. In order to use the quadratic formula, though, we have to have it set equal to 0 to find our a, b, and c. So I'm going to move the 6x over, add 11. And so now I got x is equal to minus b. So minus a minus 6 would be positive 6. Plus or minus b squared. So -6 times -6 would be 36. Minus 4 times 1 is 4 times 11 is 44. All over 2 times a, which is 1, so 2 times 1 is 2. So this is 6 plus or minus. 36 minus 44 is -8, all over 2, which is 6 plus or minus. I can pull out 1, 2. My 2's left in there, and I'm going to pull out the negative as an I. All over 2. And just in case you got lost there, this is 2 times 4. 4 is 2 times 2. So I'm going to pull one group of 2's out. 1, 2 is left inside. I pulled out the negative as an I. And now because 2 can go into both 6 and 2, I can reduce that down. 6 divided by 2 is 3. 2 divided by 2 is 1. So I just have the square root of 2i. If you can't do it to both of them, you can't do it at all. But if you can divide both of them by the same number, then you can reduce it down. Number 23, again, you got to set it equal to 0 first. And then we can do the quadratic formula. So minus b would be minus a minus 4. In this case, it's positive 4. All over b squared. -4 times -4 is positive 16. Minus 4 times 4, 16 times 1 is 16. All over 2 times a, which is 2 times 4, which is 8. 16 minus 16 is 0. So this is the case where we're just going to have one solution, 4 divided by 8, because there's plus or minus 0, and that would reduce down to 1/2. That's the case where the parabola, in this case, it's opening up. So it would go down, it would touch that x, well, pretend like that's touching. It would touch the x-axis at one spot and then bounce back up. All right, discriminant is b squared minus 4ac. It's this part of your quadratic formula. It's what's underneath the square root sign. And from that, we can tell several things about it. If the discriminant is 0, as you just noticed here, our discriminant was 0 and we had one solution. If it's a negative number like we had here, you end up with two imaginary solutions, not irrational, imaginary solutions. If it is a positive number, but not a perfect square, you'd have two irrational, which means you're going to have a square root sign in there. And then if it's a perfect square under there, then you would have two real solutions. So let's see if we can figure this out. To find a discriminant, we still have to get everything set equal to 0. So we have the right A, B, and C. So if I wanted to find the discriminant for this one, it would be B squared minus 4 times A times, oops, that's not positive, this here is, that's negative, times negative 6. Negative times negative 4 times negative 4 is 16, minus times a minus is going to make that positive. 4 times 5 is 20, times 6 is 120. So this is 136. So it's positive. So I'm going to know I'm going to have two solutions. If it was a perfect square, they would be real. If it's not a perfect square, they're going to be irrational. In other words, there's going to be a square root involved. So since it's 136 is not a perfect square. So this is going to be two irrational solutions, which just means it's going to have a square root in the answer somewhere. All right, let's try 25. We're going to move this negative 4 over and find a discriminant. So minus B squared minus 4 times A times C. Negative 8 squared is 64 minus 4 times 4 is 16 times 4 is 16. Our discriminant is 0, so we're going to have one real solution. All right, that's the only examples they gave us. Again, if you came up with, let's see, say 36, that's positive, and it is a perfect square, this would give me two real solutions. And if you came up with any negative number, that would give you two imaginary. Anytime it's a negative discriminant, it's going to be imaginary solutions. So those are your 4 options. All right, number 26. Which statement best explains why the solutions are irrational to the quadratic equation? Well, if we look at the discriminant of this guy, it's 1 squared minus 4 times 2 times negative 7. So this is 1, and then negative times negative is positive. 4 times 2 is 8 times 7 is 56. So 57. So what is the best reason why it's going to be irrational? Is because it's positive. You might be just tricked into thinking it's that. It is positive, that's true, but that's not the reason why you have irrational. Because remember, you could have positive that was, say, 64. That's a perfect square and positive, and you'd have real solutions. What makes it irrational is this guy is not a perfect square, which corresponds to D. If the discriminant is 0, you're going to have one solution. If the discriminant is negative, you're going to have two imaginary solutions. All right, which equation has one real rational root? In order to have one real rational root, my discriminant has to be 0. So for this one, b squared is negative 2 squared minus 4 times 1 times 5. That would be 4 minus 20, not going to be 0. All right, negative 5 squared minus 4 times 1 times 4. That's 25 minus 16, not 0, not that answer. C is negative 3 squared minus 4 times 1 times 1. That's 9 minus 4, not 0. So God willing, it's D. Let's try that one. 10 squared minus 4 times 1 times 25. Winner, winner, chicken dinner, right? 10 times 10 is 100. Minus 4 quarters is 100 or $1, and that's equal to 0. So the answer for 27 is D. All right. Looks like we're on the last page, but I do not have enough time to make that into this video, so I'm going to stop here and we'll do one final video.